Okay, here we go on this review sheet. Hang on one second. All right, so remember your quadratic formulas up here. Your discriminant tells you about what's happening inside the radical. So let's go. So we're going to solve this. It says, what am I going to use? Factoring or square roots. So you cannot use square roots because it has this x term here. So when you're going to use square roots, it can only have x squared anywhere in the problem. You can't have a single x term like that. Or you could have, if you're going to use square roots, you could have the parentheses squared, because I'm going to get rid of the 12 and then do the square root to get rid of that. But like here, I can't use square roots because of that x term right there. So anytime that's present, you can't do square roots. And you prefer to do square roots because it's a little faster and easier. All right, so we are going to factor this. So doesn't divide by anything, no GCF. So we're just going to start off 2x and x. I got to get 6. So I think I'm going to try 6 and 1 because I noticed right away that 2 times 6 is 12, and that gets me close to 11. So 6 and 1, and I can't put the 6 here. All right, so let's look. 12x and 1x. Negative 12 plus 1 makes negative 11. So we're all set. So remember, the long way to do this is to take 2x plus 1, set it equal to 0, and x minus 6, set it equal to 0. So these are going to be your zeros because one of these two things has to equal 0. So you're solving them and seeing when they're 0. So this one gets you 6, and this one gets you negative 1 over 2. So negative 1/2 and 6. All right, now don't forget, you can also graph this on your calculator. So go to y equals. First, let me clear my calculator. Second, plus, and then 7, 1, 2. All right. So I need this one to type in here because it's so 2x squared because it's set equal to 0 minus 11x minus 6. Okay. So if I press graph, I can kind of confirm that it's crossing at 6 and negative 1/2. So there's my negative 1/2. There's my 6. So I'm very certain. Also, I can press trace, type in 6, and see how 6, 0, and negative 1/2. And there's the other one. So I can really confirm it very well. All right. All right, over here. So in my solution set, let's see. I'm going to use square roots because there's no x term, so I'm going to take away 5. Get rid of that. We got 3x squared equals 72. Divide by 3. Let's see, 72 divided by 3 is 24. So then I will take the square root of both sides and get x equals, don't forget my plus or minus. So let's see, 24. I think I'll use 6 times 4 because 4 is a perfect square and 6 only breaks down into 3 and 2, so I don't have to do anything else. So I'll say 2 radical 6. Now remember, if you needed to confirm, 2 and then square root of 6, I mean that's 4.9 basically, so it's plus or minus 4.9. Now confirming these is a little bit more annoying because what you have to do to solve it for 0, I would probably go this last step and like move the 24 over. So I have x squared minus 24, all right, because like that was my last step. You could do it up here, but like it's easier here. And so when I graph it, and so see those points right there, what was it, 4.9? So if I go here, 1, 2, 3, 4, and it looks like almost 5, right? So if I trace and press 4.9, it's basically 0, but 4.9 is rounded off. Okay. All right, so we're going to use square roots on this guy because I do not want to multiply this out, right? So I'm going to take away 12. I got x minus 4 squared equals 36 now, and I'm going to do my square root. Now, lucky for me, the square root of 36 is 6, so plus or minus 6, and x minus 4 pops out. That negative 4 is going to pop over to the other side and become a positive, so 4 plus or minus 6. And I forgot to write my answer here. There we go. All right, so this is done, but I have to actually get the answers, right? You don't leave me like math to do. So what is 4 plus 6? I would say 10, and 4 minus 6 is negative 2. Like this is the expression to get the answers, but it's not the answers yet. All right, I can't use square roots, so I'm going to use factoring. So can't use square roots because of this. This negative 19x needs to come over to the middle. It's 19x, and then plus 20. Now, it's important to note too, not everything's going to factor. But because I'm asking you which one you're going to use here, obviously, like I've given you problems that will factor, but if it doesn't factor, you have to use a quadratic formula, which we'll do down here. All right, so nothing divides, so I'm just going to start factoring. Let's try 5 and 4. Ooh, I think I see it. 5 here and 4 there. See how that's 15 and 4 to make 19? Both positive. So 15x and 4x. All right, so either 3x plus 4 equals 0 or x plus 5 equals 0, which leads me to negative 5 and also negative 4/3. Okay, so negative 4/3 and negative 5. And again, you could type this one into the calculator, this part right here, into y equals and confirm it. Okay, we're going to use a quadratic formula. So it's up here on our paper. So I want to, everything's all prepared. It's all on one side. So 2, negative 5, and negative 1. And it's a good idea to find that discriminant. Remember, the discriminant is b squared minus 4ac. We're going to do some of it in our head. Negative 5 when I square it. And if you really need to, but everybody knows how to square negative 5, right? Negative 5 times negative 5. Or parentheses negative 5 squared. There we go. It is not negative 5 squared like this. That's wrong, because you're not taking the negative with you when you square it, so you get the wrong answer. You get negative 25. I can't tell you how many times I've seen kids do that, and then they get the wrong discriminant, and you get the whole problem wrong. Okay? So it's 25 minus 4, and just put a spot for a and c, 2 and negative 1. All right, and then just put that right in your calculator. We got 25 minus 4 times 2 times negative 1. Okay, get 33. All right, so let's set it up. X equals big fraction. A negative of negative 5 would be 5 plus or minus the square root of 33 all over 2 times 2, which is 4. So looking at that, 33 does not reduce. Oh, I'm finished. So my solution set is 5 plus or minus radical 33 over 4. Okay. All right, so over here on number 6, I'm going to move that negative 5x to the middle, so it becomes 4x squared plus 5x minus 8. So 4, 5, and negative 8. And my discriminant. So again, b squared, 5 again, so 25 minus 4 times a and c. So a turns out is 4 also, and c is negative 8. All right, that 4 is always there. It's part of the formula. All right, so 25 minus 4 times negative 8. All right, 153. All right, so let's check out 153 a little bit. Yeah. All right, let's just make sure. 153, let's divide it by 3. Oh, it does divide by 3. I wasn't sure. Anyway, well, I guess I should have known that. And then 51, let's try that one divided by 3. I was trying 3 because if 153 was odd, so I wasn't going to try 4 or anything like that. So it divides by 3 twice, so that means it divides by 9. So 153 divides by 9 and becomes 17. So 9 times 17 is 153. So that means when I go later, when it's in my radical, it'll be 17 times 9, and I'm going to need that for my reducing later. All right, so let's do it. Negative b, so negative 5 plus or minus. It's going to be the square root of 153 over 2 times 4, which is 8. All right, so negative 5 plus or minus, we learned we're going to bring a 3 out, all over 8. Now, these 3 numbers do not reduce, but like you learned in class, if they do, you reduce them and then rewrite your answer, but they do not here. So negative 5 plus or minus 3 radical 17 over 8. That's my solution set. Okay. All right, one more time, quadratic formula. So I had to take away 2x to get this together and add 3. So that means my problem becomes x squared minus 9x plus 8 equals 0. So 1, negative 9, and 8. My discriminant is b squared, so 81 minus 4 times 1 times 8. All right, and so I got 49 for that. So that's going to be nice. My answer, I got negative b, so that would be a positive 9 plus or minus the square root of 49 all over 2 times 1. So this is something I actually know. Square root of 49 is 7. So I got 9 plus or minus 7 all over 2. So I should figure this out. So 9 plus 7 is 16. So I got 16 over 2. And 9 minus 7 is 2. So I got 2 over 2. So 1 and 8 are my final answers. I'll work it out when I can. All right, here, just don't forget your factoring. These are perfect squares. X plus 7 and x minus 7. Done. These here, let's see, they all divide by 2, so I'm going to pull that out. So x squared plus 7x minus 18. And then when I'm done, my 2 is still there. Let's see, we'll use 9 and 2. Plus 9 minus 2. Okay, we did harder factoring on the front. All right, so let's take a look here. So label my graph. I got 3, -1 for my vertex. I have on the right side, it's going up. So double it, positive infinity. This is left and up, so negative infinity and positive infinity. All right, my vertex, 3, -1. My domain is my smallest and my largest x value, so that would be negative infinity to positive infinity. Also, the graph is opening out forever. My range, it's going down to -1 and up to infinity. It's touching -1, so bracket. So that's my height. It's starting at -1 and going up, 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 up. All right, increasing. So the positive slope is on this side. It begins going up like right here, right? So from 3 over, the graph is rising, like a positive slope. So from 3 to the right. The negative slope occurs here. So this side has a negative slope to it, so it's decreasing. Because when you come to the graph, I know it's going up, but when you come to the graph, it takes you down, right? You read it from like left to right, so down and then up. So everything before 3, so negative infinity to 3. Great, x-intercepts. Let's see, we got 2, 0 and 4, 0. Right, y-intercept, oh, I can't tell from the picture, but let me see. When we get the equation down here, we'll come back to that. All right, my end behavior. Well, both ends are going up. The right side is going up. The left side is going up, and the answers are right there. All right, so let's check out my equation. My pattern goes 1, 1, 2, 4, so it's a normal quadratic. Oops, the y equals is already there. It's facing up, it's moved to the right 3, so x minus 3 squared, and then minus 1. So let's find that y-intercept. For the y-intercept, I plug in 0 because I can't see it up here. It's probably going to be about 7 maybe, but let's check it out. I plug in 0 for x, so it'd be 0 minus 3. So that would be -3 squared. -3 squared is 9. And then 9 minus 1 is 8. So actually 8. All right, some review down here. So f of 6, that means I need to plug 6 into this problem. -4 times 6 plus 5. So put that right in your calculator, or -24 plus 5 is -19. h of -4, so there. So 2 -4 squared minus parentheses -4. All right, so again, put in your calculator, or this turns into positive 16, so 2 times 16, minus minus turns into plus 4. So that's 32 plus 4, so that's 36. All right, so this right here, this also just means subtraction, right? It just means h of x minus f of x. So h of x is 2x squared minus x. It's that minus this guy, -4x plus 5. So put them in parentheses. These parentheses don't do anything for you. But this one, minus minus, turns into plus 4x, minus 5, and then combine like terms. So 2x squared. These two go together, make positive 3x, and then minus 5. All right, over here, this just means f of x times g of x. So we're going to multiply them. So f of x is -4x plus 5. We're multiplying it by 3x plus 2. So hopefully you know by now this means to FOIL. -4x times 3x is -12x squared. -4x times 2 is -8x. Inside is plus 15x. And 5 and 2 make 10. Clean this up. Get positive 7x plus 10. And that is finished. All right, so here, we're going to change the vertex form into standard form. So we do want to multiply this out here. We're not trying to solve this, we're just trying to change it into the other format. But before I do that, let's look at the vertex. Left 5, down 8. So left 5, down 8, that'd be -5, -8. and it's good to find the vertex when something's in vertex form, right? All right, so let's work this out. X plus 5 times x plus 5 minus 8. So we get x squared plus 5x. So this is why we learned how to FOIL and do all these things, because you need it here. You get another 5x in the middle and plus 25. And then the minus 8 just hangs on. So clean this up. X squared plus 10x. And what's that? 17. All right, so my standard form of h of x is x squared plus 10x plus 17. Okay. All right, now over here. So exactly like one of your homework problems you've had before. Find the vertex. We're using this formula. This is the beginning of the quadratic formula, right? Right now, this is in standard form already. So negative b over 2a. So negative of negative 8 would be positive 8. 2 times 1 is 2. So 4 is the beginning of the vertex. To find the end of the vertex, I got to plug in 4 into this problem. So 4 squared minus 8 times 4. Any point that I want, I just plug it in. Plug in the x value. So we got 16 minus 32 minus 20. Oh, gross. So 16 minus 32 is negative 16. Negative 16 minus 20 more is negative 36. Or put that in your calculator. All right, so we're going to factor this and use it to identify the zeros or the x-intercepts. So x and x, let's see, 10 and 2 make 20 and also 8. So 10 and 2, I want a minus 10 and a plus 2. So that means when I set these equal to 0 and find my zeros, what makes a 0 is 10. So x equals 10, and what makes that 0 is negative 2. Again, I could check it and make sure. Let's do x squared minus 8x minus 20. All right, so negative 10 and negative 2. Uh-oh. Oh no, positive 10. I was like, oh no, how'd I get it wrong? 10 and negative 2. Yeah, sorry, I thought that was a negative sign there. Okay. All right, use the graph of this parabola to write the vertex form. So we want, I guess it's called f of x. It's upside down, so I'm going to need a negative. The pattern is 1, 1, 2, 4, so there's no stretch or shrink. Let's see, let's move to the left one. So x plus 1 and up 4. The zeros are x equals negative 3 and positive 1. Or you could put them as points. And what are the other 3 names for the zeros? They are called x-intercepts, roots, and solutions. Okay, all right, last question here. Keaton decided to solve the quadratic equation using quadratic formula. So that means he was doing this formula. All right, and he calculated the discriminant and got a negative 12. So that means that inside the radical, he now knows is a negative 12. And we haven't taught you how to deal with that negative yet, but I have taught you that that means that these are not real solutions. There's no real solutions to this because you can't do the square root of a negative for now, all right? What does he now know about the solutions he's going to get? He knows that there are going to be no real solutions. So that means that the picture is not going to cross the x-axis. So depending on the rest of the problem, he's going to like have a graph like this that never touches the x-axis and it's facing up, or he would have a graph that's like upside down and never touching the x-axis. So you can't be up here upside down because eventually you would cross. So you have to be underneath the x-axis that way. Okay, so you don't need to know that this means this necessarily, but that's what it does mean. All right, I'll see you later. Bye-bye.